We are from the Vice College of Engineering, Savli. I am Amrita Sogli with my colleagues
Kilendra Pardi,
Vinita Narfin. We are here to represent our project Energy Conservation for Street Light and Automation using zigbee. Nowadays, electrical energy is so widely consumed, so it is necessary to manage it in a systematic way. Our project provides solution for this. The aim of this project is to develop a system which can detect faults in street lamp, report it to the utility and hence increase the life of street lamp. Some of the common problems occurring in street lamp are open circuit and flickering. When a lamp gets open circuited, it draws zero current and doesn't emit light. And when it edges, start flickering, drawing fluctuating current and contributes to the energy wastage. Both of these problems cause inconvenience to the society.
now I am going to explain the block diagram.
Here I am going to explain block diagram. We know that faults occurring in a street light can be detected by measuring the current drawn by street lamp. To sense the current drawn by street lamp, a current transformer is connected in a series with lamp load. The output of current transformer is a bipolar current signal. This is processed using a current conditioning circuit icon and converted into a unipolar voltage signal. As we know that lifespan of street lamp can be increased by operating it within the operating voltage. The voltage across the lamp load is sensed using a step-down transformer. The output of step-down transformer is a bipolar voltage signal. This is processed using a voltage conditioning circuit VCON and converted into unipolar voltage signal. The output of current and voltage conditioner is connected to the analog input of TIIC EADC RF2500 kit, which runs in-device firmware to transmit the load current and load voltage and also operates a relay. At the utility end, TIIC EADC RF2500 kit running the hub firmware for collecting data from in-devices to the PC. The data received from the in-devices is displayed in a GUI developed using the MATLAB.
Now I will explain the analog design of our project. Same circuit is implemented here. This circuit is powered by ±5 volt supply. Bipolar current signal from current transformer is connected to these pins and bipolar voltage signal from step down transformer is connected to these pins. These two ports are used to adjust offset and attenuation is adjusted using this port. These bipolar signals are attenuated to get voltage in the range of -1.5 volt to +1.5 volt using 1 microfarad capacitor and resistors. A DC voltage of +1.5 volt is added in output of attenuator to get unipolar output voltage between 0 to 3 volt and output current in terms of voltage. Varieties of street lamp are available in the market. A street lamp consumes power from 40 watt to 1.5 kilowatt. That is, it draws current from 150 milliampere to 4.5 ampere. For demo purpose, we have used two 200 watt bulbs. So, 5 ampere to 5 milliampere current transformer is used to sense the lamp current. Dimmer is used to vary AC power supply. Output of dimmer is stepped down to 9 volt and given to voltage conditioner. In the same way, output of current transformer is given to input of current conditioner. Signal conditioning circuit is followed by peak detector. These two peak detectors uses 741 op-amp IC. They are used to detect peak value of current and voltage output of signal conditioning circuit. Detected peak values are given to the input of end device of EZ430 RF2500 kit. End device is running program to read analog inputs, convert them into corresponding lamp voltage and current values. These values are transmitted using TIIC network protocol. Access point connected to PC is running program to receive data using TIIC network protocol and send it to serial port of PC. The received data through COM port is read and displayed.
Let's see the software part and the microcontroller part.
Similarly, this kit has MSP430F2274 microcontroller and C2500 wireless kit. This is MSP430F16X microcontroller and these are the SPI-BY wires with application UART. This is graphical user interface and it is developed by MATLAB software. This field provides the AC voltage. This field provides the current taken by lamp load. This field shows the fault. Here Fn denotes no fault and FAL denotes for fault. Here we have two AC bulbs of 200 watt each. One bulb consumes 0.8 ampere current. When both the bulbs switched on, they consume 1.6 ampere current.
The AC voltage is set at 230 volts. When one bulb is switched on, it draws 0.8 ampere current. These values of current and voltage from the end device are transmitted to the utility by zigbee. And we are getting the same value on GUI. So there is no open circuit or flicker in the bulb system. When both the bulbs are switched on, the total lamp load draws 1.6 ampere current. Now these new values of current 1.6 ampere and voltage 230 volt are again transferred by zigbee to the utility point. And on the GUI, we are getting same values. This FN means no fault is present in the system. Now, if we turn off both the lamps, it will be open circuited and it draws 0 current. This value is displayed in GUI with fault detection. The voltage across the lamp can be varied. Due to this varying voltage, it starts to draw fluctuating current. It results in more energy consumption. So at the central point we can decide whether to turn off the bulb or not. In the same way, network of zigbee can be formed which will update status of each lamp to the utility, that is central unit. Depending upon fault conditions, the street lamp can be repaired or replaced in case. The continuous monitoring of all nodes from a single access point will surely help us to conserve electricity. Now last but not least, I would like to thank our guide Professor Gaikwad sir who helped us through our project, the entire electronics department who made available all the required facilities and instruments on time, and the entire Texas community to provide a platform to showcase our talent. Thank you.